Today we are going to know how we can determine the sample size, because any study depends on the study you are going to use and you are doing in this study. Okay, so you have to choose the right sample size. But before I start with the formulas and this stuff, I just remind you we have a population here. It is so big, okay, and we get a sample inside. We get a sample. Somebody else say, no, I take another sample, a bigger one, okay, I can take another sample. So we will disagree about the size, okay. This is why we have to determine the sample size, okay. This is our main object for today, as well as we have something called confidence interval. Confidence interval for what? We will go for three things to have the confidence interval for. We will go for the confidence interval for mean. I mean here the population mean, so let's go for the population mean. Okay, and also we will go for proportion or population proportion, right? And the last thing, we are going to give the confidence interval for the variance. Once we set the variance, if we take the root square, we call it the standard deviation. This is the three things we are going to have the confidence interval for. Okay. Maybe you said, what does it mean, confidence interval? I heard this word before. Yes, you heard it. You heard it when you have the bell shape. Okay. And you know this, if it is normal with a mean and variance, so your middle one will be here the mean mu, right? Because if you have in the middle the mean and also the mode and also the median, if you have all of these one in the middle, it means they are equal. It means your distribution is symmetric. Fine? Okay. We have very special normal distribution because we cannot find a table for each mu and sigma square. This is why we have the standard normal distribution. The standard normal distribution has a mean equal to 0 and a standard deviation equal to 1, so the variance will be 1 square. So here you will start from 0, right? Okay. Because what is this peak? All the time you just having here the frequency, and here is your data in any distribution. So yes, the mode give you the most frequent element, so it gives you the peak of your distribution. If you agree at this peak you have the same value as the mean, as the median, you will have a symmetric distribution. One of the popular one is a normal distribution with a mean equal to mu and a variance sigma square. If we have the standard normal distribution, it means the mean is equal to 0 and the variance, the standard deviation is 1. Okay. You heard about this one. If I'm just walking here a distance exactly like the mu. Okay, so if you choose the mu 0 and the standard deviation 1, so you take a step up from 0 to 1. From 0 and 1 step equal to the standard deviation. 1 step right and 1 step left. Okay, so what? So you have, this is the confidence interval equal to what? Yes, I hear you, 67%, right? Is it? Yes. So you said you have 67% confident that your data will be one of these one. Okay? Here, right? If you have confidence interval equal to 95, it means you walk one more step equal to the standard deviation, so you reach 2, and you have another step from the left, so this one from here to here, this is the confidence interval by 95%, right? If you walk one more step equal to the standard deviation, and we have the standard normal distribution, so the standard deviation is 1, so I move from 2 to 3, and also to the left. This is the confidence interval equal to what? Yes, I hear you. 99% or 0.75? Is it? Or 97? I'm not sure, but I think 99.75. Okay, so what? So you are confident by 99.75% that your data will lie between the 3 times of the standard deviation, positive and 3 negative, right? So your value will be in this area. This is what we call it the confidence interval. Interval mean from 2, and you write it like this one, -3 to +3. This is a confidence interval. This is your data Z lie in this one by 99.75%. This is the confidence interval that your Z will be one of these, right? Okay, that's good. This is what does it mean interval. Now we are ready, okay, to know how to find the confidence interval for the mean. We will start with the, we start with the mean. Okay, so what? So you have interval, okay, sorry. You have interval. Your population mean, you call it what? You call it mu, right? So your mu, your mean of the population will lie in this interval. What is this interval? What is the left hand side of this interval? Yes, this is why you are using the sample. You cannot study the whole population. You take a sample, and we know the type of sampling methods, right? So we take the sample, so we have to use the sample information to have this interval. Yes, I got the sample. So the mean for the sample, we call it X bar plus. Yes, I know we test the mean using the Z when we have the standard deviation of the population is known, right? So this is the right hand side for the interval. I will take the left hand side just to be organized. Z over alpha over 2. What does it mean, alpha over 2? Yes, I hear you. This is the area you left it here, it's called alpha over 2. And the area left it here is called alpha over 2. Okay? Because you have 2 tail here, right? In this case, you are having 2 tail. That's good. Times what? Times sigma over Yes, it's exactly like root square, the standard error, if you remember this one, the standard error, this one. Good. And next, yes, what is the right hand side of the interval? It is the same, but you change this one into positive, right? Okay, yes, good. So you have x bar plus z alpha over 2 times sigma over root square n. This is our interval. Some people, they don't like to use it in this case. They said, no, I am saying my population mean will be between this value, the mean for the sample I got, and z of alpha over 2 times sigma over root square n. It is greater than this value and less than this value. It's up to you. If you would like to write the interval in this way or that way, it doesn't matter. So this is, I'm saying, the population mean. So I have estimation for the population mean using the mean of the sample, right? But I have to know the standard deviation of the sample. This is the population mean estimation. Okay, fine. So I can estimate the value of the population mean using the mean of the sample or the sample mean. Good. Now, this is under one condition. When, let's write it in red. When sigma, what is sigma? The standard, okay, I'll write it down here. When sigma, what is sigma? The population standard deviation. The population standard deviation. Okay. If this one is known, okay, we go for this formula. What about if it is not known? Don't worry. You replace it by what? Yes, I hear you. If sigma is unknown, let's write in black. We replace it by sigma under one condition. What is the condition? Yes, and n greater than 30. What is n? Yes, I hear you. The sample size. Good. Okay, if the sample size is greater than 30, you can replace this one by what? Yes, I hear you. You replace that one by S. Okay? Replace sigma by in, I call it star, so I call this one star flag. Okay? So you will have the same formula, right? But you replace the sigma for the population because it is unknown, but under one condition. Okay, yes, you are right. The sample size greater than 30. Why this one? Using the central limit theorem. The central limit theorem says if your sample size is greater than 30 or so big, to be honest, it doesn't The theorem doesn't say 30. It said if your n is going to be a huge number or infinity, your distribution for the data will be close to the normal distribution. This is the central limit theorem we know before, right? Okay. Someone else says, you said greater than 30. What about if it's less than 30 and unknown? Okay, don't worry. F sigma is unknown and n less than 30. Yes, I hear you. Replace z by t. Replace z by t. What is t? The t distribution or the student distribution. The student distribution. Okay. Yes. So I replace z by t. So yes, go here and take this one and put a t and replace that by s. That's all what you are going to do in the formula. It is one formula and you change it up to the cases, right? This is what I'm doing. I have the base and up to the cases I change the formula. Okay. Now we are ready. Okay. Yes, we are ready to solve the question about having the interval, the confidence interval for the mean. But before we go, what about the sample size? If we are going to have the population mean, the sample size in the case of determining the mean n is equal to what? Z alpha over 2 times sigma over E, right? Maybe you know Z alpha over 2 and you know sigma, but what is E? Yes, E is the marginal error. This E, the marginal error, the marginal error. And we know what is sigma? Sigma, the standard deviation of the population or the population. I like to repeat this stuff again and again and again, just to stick to it. The population standard deviation. Okay, what is Z? This is the standard, or Z, you can find it from the Z table, right? The standard normal distribution. So yes, this is from the Z table, if you remember. The Z table was like that one, and you have 0.0, and you have 0.1, etc. And you have the Z. Okay. And you have two tables, one for positive Z and one for negative Z. Okay. This is a sample size when we are going to estimate the mean. Okay. So far, so good. You may ask your question. F sigma is unknown. Okay. Are you going to replace sigma by S? I have no choice. How it comes, you replace sigma by S and you don't know your sample size. So no, be careful in this case. So you should know the standard deviation of your population to be able to know the sample size. Okay, without the sample size, you cannot, without the standard deviation, you cannot have the sample size. Are you ready now? So please take a screenshot from this one and put it in the chat, please. Anyone done it? I have only female students. Girls, anyone take a screenshot and put in the chat?
Yes, doctor.
Thank you. And take for this one as well, please. Before I leave, I told you about alpha, right? So no need to yes, I talked to you about alpha. Okay. Now we are ready to solve some questions or go through one example first, right? Before we go to the exercise. This is what I said. This is what I explained to you. Okay. Oh, I forget to put this the square here. Sorry, I'm so sorry. Can you please? Yes, I forget the square here. I always do this one because I make the bracket. What's the point of making bracket without? Because the formula has a square. So please change this one. Thank you. Okay, sorry. This is a question. You are given a data here, right? Okay. But he gave you the standard deviation of the population. Okay. And he gave you 99% confidence. So it means alpha will equal to what? 100 minus 99. So I know alpha from the confidence interval. Or if he said level of significance 1%, it will be the same. Fine? Okay. What I need from this sample, he gave it to me. Yes, because the formula has X bar and sigma is already known. So this is the right one I'm going to choose, as I said here, right? This is the first case, right? Good. Can you use your calculator to find the mean? Yes, I will let you know how to do this one, and please try to go with me. Can you go for mode? Go for statistic or stat, and then go for what? Yes, VAR, variable one, because you have one variable, right? And then what do you have? Yes, you have a window, right, with X like that, right? In this column, I'm going to input my data. So I'm writing 1.9 and the press equal. To write the second one, I make column by column, right? 2.9 equal, sorry, 2.8. Use your calculator, please, to give me the right answer. And then press equal, 2.5, press equal, 3.1, press equal, 2.0, press equal, 2.1, press equal. Okay, let's go. 3.1, press equal, 3.2, sorry. And 3.0 equal, 2.7 equal, Again, 2.7 equal, 2.8 equal, 2.4 equal. Can you complete it, please? 2.0 equal, 3.8 equal, sorry, 2.8, sorry, 2.8, or 3.8. Yes, you are right, 3.8. And then 2.8 and 3.5 and 1.9 and 3 and then 2.9, 2.7, 3.2, I stop at 3.2, 3.8, 4.0, 4 equal, 3.4, 2.7, 2, 3, 3.9, 2.2, 2.9, 3.3, 1.9, 3.8, 2.7, 2.8, 2.1. I finish. Once you finish, you just press AC, please. After you finish, press AC. You have a key with a red color. This is AC. Yes, everything will be disappear, but don't worry. After this one, you press Shift and 4. Why 4? Because above 4, this is something called statistics. Is it Shift and 4 or Shift and 1?
1, doctor.
1, yeah. So
I'm
yeah. Shift and 4 a matrix, right? Yeah. Shift and 1.
It's 1, doctor.
Yes, because 1 has a statistics. Okay, you have a window here. From this window, I'll go for what? Var again. I'll go for this one. Once I go for this one, it gives me a window, has X bar, I think. Yes, this is the one I'm looking for. Press this X bar. What do you have now? What is the value you have?
0.
0.
MashaAllah.
0, doctor.
How it comes 0?
No, doctor, 2.8228571.
This is how it comes 0.
2.8. I didn't press equal.
Okay,
2.8,
no problem. That's good.
2.444.
It is better to have a mistake now when you are learning. Later on, inshallah, you'll be professional. Okay, 2.9. So yes.
Yes.
So I have X bar. The sample mean, I didn't write it, so I was waiting you to write it down. What is the value?
2.8.
2.8.
2.19.
19. Thank you. You have confidence interval 99%, so your alpha is 1%, right? I will write it in details here. It is exactly 100 minus 99 equal to this one, if you like to have it. Okay. So you need alpha over 2. So you have to divide it 1% over 2. It gives you 5 out of 1,000, right? And this is the sample size. We have it using our calculator. Okay. And we know how many, what is the sample size here? 1, 2, 3, 4, 5, 6 times 6 is 36, right? So I'm looking for the information in the formula I'm going to use. Now I go for z of alpha over 2, right? So z of alpha over 2. So I will go for the z table. Yes, z table. Let's go for any z table. Okay. It's boring. Okay, so I'm looking for what? What is z of alpha over 2? Is equal to what? 0.995. How to get this, the value of z corresponding to 0.995? Okay, what you are going to do, this is your table. Sorry. This is your table, right? So this is the negative one. I'm looking for the positive one. Why I'm looking for the positive one? Because the value of the probability is bigger than half, right? If I am over 0.5, I have to go for z positive, right? Do you have 0.995 here? Just concentrate with me. 0.995. Yes, I think this is the one. Yes, I don't have it exactly, right? But I have one less than 0.995 and one greater than 0.995. So the main value of z is 2.5, right? But the decimal after the 5 is what? Is 0.7 plus 0.8 divided by 2. So it will be 0.075. So I add after the 2.5, after this 5, I add 7.5. Why 7.5? Because this is the average of these two places, because I didn't find my probability, which is 0.995. So I have to look for one less than the value and one bigger than the value. Straightforward. So it lies here. Because it lies here, z will be 2.5 and the middle of this one. What is the middle of this one? It is in the middle here. So you have to add 0.07 to 0.8 and divide it by 2. Okay, it will be 0.075. So the second decimal place is after the 2.5 will be 7.5. Yes, I got it. Okay, that's good. So yes, it is 2.57. Now I have everything to substitute in my formula. This is the estimation of my population mean. It will lies between this value and that value. This is the interval. Start from here and end from here. So this is the estimation of my population means using the mean of the sample. So my population mean will be in the interval of this value to this value, right? So can you substitute here and give me the value, please? Hello, guys. So the confidence interval is what? Mu. I just insert symbol. Can you get mu here? I think I have it here somehow. Can you see mu? I don't see mu here.
No, doctor.
Sorry? No?
Cannot see, no.
It's going down. It's supposed to be here. Yes, here it is. Yeah, here it is. I just see it now. Yes, here. This is the one. Okay. So insert mu. So mu will be greater than what? Can you substitute here, please? X bar is 2.819 minus Z alpha over 2 is 2.575 times sigma. Sigma is 0.62 divided by the root square of n. N is 36. So what is the value?
$2.77.
2.77.
2.7.
And the right hand side? Thank you.
$2.86.
Thank you so much. 2.86. That's great. That's very nice. Now we have done our job. For the same question, I will go to use the formula to have the sample size. This is the formula. I have Z alpha over 2 is 2.575. I know sigma, he gave it to me in the question, 0.62. And he's, yes, this is the sentence I'm looking for. He said to estimate the GPA within 0.025. So I can ignore if I have value more than the estimated value by 0.25, I can ignore this margin error, right? So please replace this one by 0.025. Put this one as we have it here, 2.575, and I'll show you how to get it from the table, Z table. And you are given sigma. So please divide this one by this one and then square it and give me the n, please. So what is the sample size?
3.19.
Oh, yes. What?
3.19.
3.19, do you think so?
It is 106.09.
106.
0.09.
0.09. Do you accept the sample size was decimal? No, right?
It should be whole number.
Yes, that's so good. So we have to not round it. I don't like the word round it. We have to take the next value, right? Or the next whole value. Catch it?
So it will be 107.
Yes.
Okay.
So it will be 10 what? 7. Yes.
107. Yeah.
107. This is the main point. It's not a rounding, you just take it. Because this is the minimum sample size. If you take it bigger, you reduce the error, as we said last time when we use the sampling methods. The large sample size, the small marginal error, right? Or the small error, sample error. Catch it? I think now we manage how to find the confidence interval and how to have the sample size. If we are given the sigma, inshallah we'll take a break and get back to have a question when we don't have the standard deviation of the population sigma, right? See you after the break.